All right, today's lesson is on modeling one variable linear equations. There are a lot of real-life applications with one variable linear equations. Let's take a look at a few examples. A cashier at Burger Hut charges a customer $8.25 for a meal. The customer gives the cashier $20.25. How much change does the cashier give the customer? Well, this could be modeled using an equation. So you can say the change plus the amount of the meal has to equal the total amount he gave to the cashier. Of course, you really don't need an equation for this, but if you want to model algebra, you're simply going to subtract the amount that was charged from the amount given. And it'll tell you what the cost is, which would be $12. Change back. That's just a simple addition algebra equation. Let's look at another. Sam had $15 when he left the sub shop. He ordered a meal that cost him $5. How much did Sam have when he arrived at the sub shop? When you see something like costs, you're going to think subtraction. So X can represent the amount of money he originally had, but he subtracted that amount, $5, because he spent $5. But we know that he had $15 when he left the sub shop. So you want to know what he had originally. You're going to solve this equation. It tells us to add 5 to both sides. So the amount that he originally had was $20. All right. A baker charges $18 for a dozen of cookies. It costs the baker $15 to make a batch of dough for a dozen cookies. How many dozens does the baker need to sell in order to get a profit of at least $360? All right, so in this case, profit has to equal the amount he sells the dough for. So you know he charges $18 per dozen. I'm going to put D for dozen. But you got to subtract off the cost. It's going to cost him $15 per dozen of cookies. We already know that he wants to make a profit of $360. So I'm going to set that equal to 18D minus 15. And there you have an equation. So you solve that by adding 15 to both sides. So you're going to wind up with 345 equals 18D. And what you're going to do is divide both sides by 18. So that tells us it's not going to be an even number, but it's going to be roughly, sorry, it should be 375. But when you divide that, it's going to be roughly 21 dozens he's going to need to get at least $360. So he's going to need 21 dozen. All right, how many desks are needed in a classroom in order to divide 8 rows of desks into even groups of 4? So we're going to divide. So how many desks are needed? X is the number of desks. You want it in groups of 4. But you're going by 8 rows. So what you're going to do is you're going to multiply both sides by 4. 4 cancels out here. So the number of desks you're going to need is 32. This concludes our lesson on modeling one variable linear equations.